Viruses challenge our definition of life. Neither dead nor alive, they are simply functional or not. Viruses do not possess the machinery to replicate themselves. Yet you can even argue that they are more evolved than us. With each discovery about viruses, we realize there is so much more to learn. 10. Black Widow virus. Scientists have recently discovered a virus containing the gene for black widow poison. The WO virus specifically targets Wolbachia bacteria in arthropods. Latrotoxin kills by poking holes in cell membranes. It is believed that the venom genes allow the WO virus to break through cells and evade the host's immune system. This is the first time animal genes have been seen in bacteriophages, bacteria targeting viruses. Experts hypothesize that the virus picked up the genetic material after breaking out of a Wolbachia bacterium into a black widow cell. However, it is possible the spider stole the gene from the WO virus. 9. Infertility virus. A mysterious viral infection may be the cause of half of unexplained cases of infertility. In 1/4 of infertility cases, roughly 1 in 70 women under the age of 44, doctors cannot find a cause. An Italian research team discovered that a virus in the herpes family is to blame. It causes immune reactions that make the womb inhospitable for an embryo. Customized antiviral treatment could offer help. The team studied 30 mothers and 30 women with unexplained infertility. 13 of the infertile women were infected with HHV6A. None of the mothers had it. This herpes variety was discovered over 30 years ago but remains a mystery. HHV6A infection releases estradiol hormone, which triggers ovulation and prepares a womb for fertilization. 8. Survivor virus. Scientists have recently unlocked the secrets to a virus that can survive boiling acid. The SIRV2 virus infects a microbe called Sulfolobus islandicus, which lives in acidic hot springs where temperatures top 80 degrees Celsius (175 degrees Fahrenheit). Using a Titan Krios electron microscope to examine the specimens in previously unimaginable detail, scientists have unlocked the basic mechanism of resistance to heat, desiccation, and ultraviolet radiation. SIRV2 forces genetic material into a protective structural state called a formation to survive extreme conditions. The mechanism is remarkably similar to the spores bacteria form to survive such environments. These spores are known to cause hard-to-combat diseases like anthrax. Scientists plan on using these survival mechanisms to design a DNA package for gene therapy. 7. Multi-component virus. Normal viruses have all their genes in one viral particle. This viral ball attaches to a cell, opens, and injects its genetic material inside. The host cell begins replicating the virus. Once enough copies are made, they kill the cell, break free, and infect more. The Guayco-Culex virus is different. To become infected, a cell needs to be exposed to 4 varieties of packages. A 5th appears optional. Named after the region in Trinidad it originated, Guayco-Culex was discovered during a comprehensive study by the U.S. Army medical team to isolate mosquito-borne viruses around the globe. While researchers do not believe Guayco-Culex virus can infect mammals, they recently discovered a closely related variety in Uganda's red colobus monkeys. 6. Human endogenous retrovirus. Roughly 8% of the human genome comes from ancient viruses. Retroviruses reproduce by inserting their genetic material into a host and hijacking its replication machinery. Occasionally, these viruses infect sperm and egg cells. If these cells survive, they go on to create an organism containing the virus's DNA in every cell. These are referred to as endogenous retroviruses, in humans, HERVs. The vast majority are considered non-functional fossils. However, a small portion are still intact and can make infectious particles. Despite being millions of years old, the HERVK group of viruses appears capable of replicating. Researchers recently discovered a variant that contains no mutations that would downgrade its function. It is believed that this HERVK remained alive within humans until recently. Scientists are unsure whether the dormant virus could re-emerge. There is speculation that HERVK might have been selected for a survival advantage it offered. 5. Bourbon virus. A Kansas farmer recently died from a mysterious tick-borne viral infection. The man's symptoms began with nausea, weakness, and diarrhea. Lung and kidney failure followed. Doctors treated him with antibiotics, the standard course of action for tick-borne illness. Nothing worked. After 10 days in the hospital, he was dead. With only one confirmed case, doctors are clueless about the disease's full spectrum. It might be a killer. Or this might be a rare case in which a mild disease became deadly. The best defense is to avoid tick contact by wearing long pants, using insect repellent, and performing frequent tick checks. 4. Siberian giant virus. A French research team recently unearthed a 30,000-year-old giant virus from the Siberian permafrost, and it's still infectious. The virus was discovered in a soil sample from 98 feet beneath the ground. It is wider than other giant viruses, and large enough to be seen through a standard microscope. The team fished for viruses using amoebas, their target hosts, as bait. The amoebas started dying, and researchers discovered they were laden with these ancient giants. Unlike most viruses, which attack the nucleus, Sibiricum sets up replication factories in the host cytoplasm. Although Sibiricum only targeted amoeba, another giant virus dubbed Marseille virus recent infected an 11-year-old boy in France. It is possible that dangerous viruses also lurk deep underground. More than any other factor, human activities like drilling and mining are likely to unearth these slumbering monsters. 3. Deep-sea virus. Researchers now believe there is more biomass inside Earth's dark, nutrient-deprived depths than anywhere else. In the ocean depths off California, they recently made a remarkable discovery into that mysterious biomass, a virus that infects methane-eating archaea, small bacteria-like organisms, on the ocean floor. Samples were collected from a deep methane seep by pushing tubes into the ocean sediment. Back in the lab, the sediments were fed methane, which triggered archaea growth, along with their viral parasites. The virus selectively targets one of its own genes for mutation. So do the archaea. The target of the mutations are the tips of the virus, which come into contact with their host. It is a countermeasure against archaea's own selective mutation defenses. This has led to a deep-sea arms race. Partial genetic matches between the California deep-sea viruses and ones discovered around Norway suggest global distribution. 2. Mysterious paralysis. In 2015, a wave of American children suffered from acute flaccid paralysis. The outbreak coincided with the flaring up of another respiratory disease caused by the enterovirus EVD68, a relative of poliovirus. Many suspected a correlation. However, EVD68 is not known for causing systemic problems like paralysis, and it was only found in 20% of the cases. A case from Virginia led some to believe that the cause might be from another virus called C105. Before the Virginia case, C105 had only been identified in Peru and the Republic of Congo. The disease is associated with respiratory problems. However, a few African cases were linked with paralysis. The C105 theory could explain why 80% of the patients tested negative for EVD68. Yet none of the patients were found to have enterovirus in their spinal fluid, which would account for the neurological symptoms. The cause of the outbreak remains a mystery. 1. Undiagnosed hemorrhagic fever syndrome. South Sudan is plagued by violence, hunger, and now a mysterious viral outbreak. So far, 10 people have died from Ebola-like symptoms of bleeding, fever, and vomiting. However, Ebola is not the culprit. Doctors have dubbed the disease undiagnosed hemorrhagic fever syndrome. Last year, Darfur in Sudan had 129 fatalities from an unidentified illness. It is not yet known whether they are the same disease. Blood samples for infected patients have revealed a host of viruses, anyang-nyang, chikungunya, and dengue fever. However, none explain the 10 deaths, and none contained Ebola. Most believe this is a virus spread by ticks or mosquitoes, but some are not ruling out the possibility of a bacteria or parasitic origin. So far, there is no evidence of person-to-person transmission, and 75% of the victims are under 20. Violent civil war and underdevelopment in the region prevent effective research into the disease's origins. One like for those doctors who were facing coronavirus.